Look, Ma, no wires. Check it out. This is John Darst with Darst Light Show, and I've got a entirely custom build here that is a self-contained 100% mobile light show controller. Check it out. Got more to show you. Alright, I got a really cool toy to show off today. This is a 100% custom build that I did for Miss Sherry Cohn. And if you're local, you know Sherry Cohn from Addy's Lights out in Detroit, Texas. And if you're not, you probably know her from PPD if you're involved in X Lights or various other communities, because she's very involved in lighting. If you know Sherry, she did have a fall last year and an injury with that, and she is now moving her light show to be mobile on her scooter named Ruby. So with that, she needs a mobile light show controller. So this that you see is a 100% mobile, self-contained light show controller. It does the whole 9 yards. So if we pop it open here behind the scenes, you can kind of see everything because it's this nice clear box that kind of shows off the build. All right, a lot packed in here in one enclosure. And like I said, it's entirely mobile. So right here at the bottom, this is a battery pack that powers the entire thing. All right, it's a rechargeable battery. We actually have 2 of them, so that Sherry can swap them in and out. And with that battery, then it's going to power this entire unit and all the attached lights. And I'll step through each piece of this. So we started our battery, and so we did a little custom wiring job here. So she's got a SAE automotive connector to make things easy to pull in and out. So that way when she wants to replace the battery, she just pulls it out, disconnects the plug, swaps the other battery in. Pretty straightforward. That plug is going to go through some power protection, because basically I wanted to keep everything safe and all the wiring protected, especially being on mobile and right there next to Sherry. I felt that was very important. So when we leave the battery, first thing to protect all our wiring is we go through a 20 amp circuit breaker. So this is an automotive circuit breaker available from Amazon, and that's the very first thing we go through. That way all the wiring and all the supplies, everything inside, is all protected. So we're going to go from the circuit breaker, and you can see I have a couple of wires that leave the circuit breaker, and that's for good reason. Okay, basically what we're going to do is we're going to bring that power down, and I am going to run through a button that will turn this entire unit on and off. But generally these buttons aren't designed to handle 20 amp loads like our setup here is. So in order to facilitate that, this actually turns a relay on and off. And if you can see this button here on the side, you can see right now it's off, and when I go down here and I press it, it will turn on. Our little relay here turns on, and this is a contact relay. So what's going to happen then is we see the red wires coming in and going back out. That's this red wire from over here that turns on the power. We go from this relay up to this voltage regulator. So this is a buck boost voltage regulator. And what it's going to do is basically stabilize the voltage, because as batteries drain, their voltage can change, and that can change some of the different controls. And basically you wanted to make sure that that stays right at 12 volts. So this will do that automatically. So if we start at 12.8 volts and we end up at 11.5 before the battery shuts off, we can keep everything running smoothly with that buck boost converter. Okay. So we come out of the buck boost converter, and then we go over here, and this is power distribution. Okay, so to distribute power, basically, you might recognize one of these. This is actually another automotive utility. So these are made for putting under the hood of your car to be able to distribute accessory power and custom builds and that kind of thing. I chose to use this here in this build, again, because of the high current rating. A lot of the light show power distribution blocks that are available, or power distribution boards, they're not rated at the current that we need. Like, they're rated at distributing 5 amps and fused for 5 amps, and the traces on the circuit board can't handle any more than that. So I needed something where we could distribute at least 20 amps in order to get over here to our light show controller and have full current ability. So that's exactly what we did here. So with this, we're also able to independently control the power to each one of our components. So I'll briefly explain each one of those here. So you see there are 4 different ones. All right. So I've got 4 key elements going on. One of them really has nothing to do with the light show controller. So right over here on the side, if you see this, I've got a nice little voltage monitor. So that's just a way to be able to keep an eye on things. And we pop this open and we've got phone chargers. So USB-C and USB-A phone chargers. So Sherry could keep her phone charged while she's playing her music if she needs, or anything like that while she's on her cart. So then we come back over. So there's one. Next one is we have our FM tuner here. So we can actually hook speakers up directly to this box. And that's what these white cords down here are for. So we can hook speakers up, and that's got our mobile speakers taken care of. And then our third one, let's see, is this small little box over here. So that's actually for a nifty little controller that I'll show you in a little bit, where we can independently turn the show on and off from a remote control. And then our fourth powered unit is the controller itself. Okay, so that's our 4 fused outputs, each one independently isolating a different portion of the build. Okay, so on these internal parts, this is all pretty regularly available stuff, and actually about 90% of this came from Amazon. So battery came from Amazon, relay came from Amazon, push button came from Amazon, 12 volt came from Amazon, or the voltmeter, display, and USB charger. The buck boost came from Amazon, circuit breaker came from Amazon, fuse block came from Amazon, FM tuner came from Amazon, remote control came from Amazon, and this is a Kulp K-8 Pi. Okay, so that's our light show controller. So it's actually a Raspberry Pi down here at the bottom with a Kulp board attached to the top called a K-8 for 8 outputs. And that's all contained here again inside the controller. Okay, so the only outputs are all over here on the right. All right, so again, I have the power button, I have the voltmeter with USB charging, I have 8 wired X-Connect outputs, and on each one of these got that nice little custom clip showing the output number. We've got quick disconnect speaker cables. So these are 2 conductor quick disconnect cables that ultimately will wire into speakers once I get those from Sherry. And then you can see peeking through down here at the bottom, this is another USB plug. Now what could that one be for? Alright, I am glad you asked. Alright, this USB is just for charging. This USB is actually a connector that connects through underneath and comes over here to our Kulp K-8 Raspberry Pi. So that's a USB connection to the Raspberry Pi. And then we've got our 2 speaker wires. And then finally over here, got this nice little weatherproof connection for an Ethernet connection to the Raspberry Pi. For either programming or connecting it to a network, you can connect it there. Now, with this Kulp, it's actually running FPP, like all the Kulp boards do. So Sherry will be able to load her show onto this controller, and it's going to do everything. So it plays the music, it plays the show. She could even add additional controllers. So if we wanted to expand and do more, it has expansion outputs. So it is really a nice little unit. So we could go and put more Ethernet plugs over here if we needed to. All really nice, self-contained. The one thing we haven't done yet is all of our final load testing. We've estimated how many pixels we can run and for how long they can run, but we've got to do the real deal. That being said, let me show you the real deal. So I'm just going to put this into test mode quick, and we can see I'm just running through a little red, green, blue sequence. Now, this is the cool part that I just got added in today at Sherry's request. So this is a remote control. See the little on and off? Watch the magic happen. I turn things on, turn them off. Turn them on, turn them off. All right. And that's just done through this little box is what this remote's communicating with. And then that is wired up to the Kulp board on what are called GPIO pins. Okay. There are a lot of questions in our small community about how exactly to do that. Turned out it was really simple. Basically just this is a contact relay output, and you wire it up to your input. So whether it's number 7, 9, 11, and to ground. This already has resistors built in, so you don't need to load the contact or anything. The tricky part is in the FPP config. You don't use the first set of GPIO inputs. You have to go down, and I'll throw a screenshot of that in the video when I put everything together. So it's all in all pretty clean. Let's see, the only other thing, I did a couple of custom 3D parts. So some of these are kind of offset off the backplate. Those aren't 3D. So, but I kind of raise things up so I can run some of the wiring behind it, just kind of keep things clean. Same thing with FM tuner here, just kind of get everything kind of squeezed in right. You can see that's on a standoff. But then down here, I did some little 3D brackets around the sides of the battery. And the battery is not held in, you can see. What those do is those just kind of keep it snug side to side and top to bottom, so you can't move it that way. And then when you close the door, everything is held in. Let's see. And and then I custom designed a 3D bracket for the Kulp board, because basically it's not flat on the back because it has a Raspberry Pi underneath. So the Raspberry Pi is only about this large. So you have to do kind of a custom little bracketry to get everything offset. So I customized that, and that was really about it. This box came from Amazon. Already has a backplate with a 5mm grid. So as long as you can kind of flex things around to meet that 5mm grid, you can use M4 bolts and they'll bolt right into it. So no kind of drilling, or didn't have to customize any backplates or anything like that. It was actually a pretty straightforward build in that regard. And like I said, all entirely mobile, kind of does its own thing. If you have any questions, hit me up in the comments. This is our wiring diagram, at least at a basic level. So we will start over here at the left. This is our 12-volt battery source. So we go through a 20-amp circuit breaker, and then we branch off in two directions off the post of that breaker. And we're going to go through a normally open relay. So this has no connection in normal state. We have that push button that's mounted on the outside of the box, so that when we close that button, now it's actually a maintained button, but when we close that button, it's going to charge a coil. Okay, so once this coil is charged, this switch closes, and then our high current 12 volts passes through this relay and goes directly into our buck boost converter. Okay, so this is what maintains that 12 volts, or at least right at 12 volts. Whether we're coming in high or low, it'll regulate to 12. We distribute in 4 directions, so we go through 4 different fuses. I think the K-8, we have a 20 amp, and I think I have 5 amp on the remote, a 5 amp on the amplifier, which is larger than they need, but the smallest I had and sufficient for the wiring. And then finally for the USB charger, I think I have a 10 amp on that. So that's what it was rated at. So then we have our 4 devices all tied back through their commons, and those commons all are shared in that automotive assembly. So basically these 4 posts, and the fuses are all part of that black automotive fuse box that was just below the amplifier. So these and this are all actually contained in one unit. It was just easier to draw them this way. So then that common returns, so it all attaches to the buck boost over here. And that is the circuit diagram. Pretty straightforward. If you have any questions, drop them in the chat. Otherwise, thanks for viewing the video. Be sure to give us a like and a follow, and we appreciate you.